Okay, let's look at CO2 in the Earth's atmosphere. Well, it used to be a lot more. And what am I talking about? A lot more. I'm talking about 1,000 times more, but I'm talking about the times before and during the dinosaurs. So we've got much warmer temperatures, but these warmer temperatures brought on the development of life. Yay, good for that. And then when you start getting to plants, you start seeing photosynthesis process. And what does photosynthesis do? Photosynthesis takes CO2. Let me see if I've got it written down. No. Oh. Photosynthesis takes CO2, mixes it with water, takes some energy from the sun in chlorophyll, and converts it to oxygen. That's what we want to breathe. Yes, indeedy, and other animals do too, and glucose, sugar. So what happened after millions and millions of years, now the Earth's about 4 billion years old, and we're talking maybe 500 million years ago. Ooh, this is what was occurring. Now, if we look at the more recent history, we can see back to 1860, and notice over here, I've got the parts per million on the y-axis, and I've got 290 is where we were then, and they're getting this from ice core data. They're pulling gases that have been trapped in ice. And you'll notice that the amount of CO2 concentrations has gone up, up, up. Boy, this is one job I would not mind to have as you go to Mauna Loa. This graphic stops at the year 2000. Oh, let's keep going. Well, May 10th, 2013, CO2 reached a milestone. Now they're at 400 parts per million. First it was in the Arctic, then they found it in Mauna Loa in Hawaii. Now, the best evidence suggests, we can't know positively, this is the highest in the last 3 million years. They can find samples, and they have better ideas and much more evidence for it being much lower all the way back to the year 1000. All right, ice core data for the first 800 years shows 280, then we start going up. The Industrial Revolution, the accompanied combustion of fossil fuels, powered that transformation. And now the last 400,000 years. And again, these are lots and lots of graphs, but what I would be very happy if you would take a look at the last period. We're looking at intervals of 100,000 years. And then you look at the point 0, and you can see she jumps quite amazingly high. Okay, so remember, a million years seems like a lot, but the Earth's at 3 billion, or 4, I'm not remembering, but that's quite 1,000 times a million years, of course. So we have a lot of time where people and animals were not on around, and that is when they had the very high CO2 amounts. But in the relatively recent history, where animals, man has been around in his current state for about 1 million years, the levels of CO2 have not been as high by far. Okay, so what we have here is two graphs where you have CO2 levels being graphed against temperatures. The temperatures, you say, it's interesting, they have been found by deuterium content. That's the isotope of hydrogen, and it's been in water. So what they've been looking at is ice. I still like magenta. So we've got temperature here, and it has been inferred by deuterium. If you remember, deuterium was written as a 2 up here. Deuterium has a hydrogen, deuterium is the isotope of hydrogen that also has a neutron. So hydrogen has 1 electron, 1 proton, and if you add a neutron, we call it deuterium, and he's got a mass number of 2. The other one is tritium, that has 2 neutrons and has a mass number of 3 and is very unstable. So the amount of deuterium around depends upon temperature, and that is how they were able to figure out by ice samples again. Up here, we're looking at CO2 trapped in ice bubbles, and they seem to move together. What we have, and it's important to realize, is a correlation, but not a causation. The data is not good enough. It is not good enough to say one is causing the other, but you do see a very definite correlation. Okay, the CO2 versus temperature over the last 400,000 years, they correlate pretty nicely. Surface temperatures, this is for global, and if you look at from 1880 to 2000, and again, we have error bars, we have ranges, and the trend is what is important to look for. And here's US. Again, with its error bars and its jumps all over the place. It's not a beautiful smooth curve. It's just too complicated on this laboratory we call Earth for that to happen. But the trend is noticeable. And what do we know today? CO2 levels and fluctuations correlate to global temperatures and fluctuation. Yep. The concentration of CO2 in the atmosphere has been increasing over the past century due to fossil fuel use. Again, they can look at isotopes of oxygen to determine whether they're coming from you breathing, from natural production in other ways, or from burning fossil fuels like coal, natural gas, and oil. Land use, cutting down trees, is another significant but smaller contribution. About 20% of the increase in CO2. But we've seen a 36 to 40% increase thus far, and are expected since the onset of the Industrial Revolution, and in the past century, So the Industrial Revolution is over 150 years old. They're expected to double in the next 50 years. CO2 levels in the atmosphere are higher than they've been the last 400,000 years, and very well may be the last 3 million years. Average global temperature has increased over the past century by 0.74 degrees Celsius or 1.3 degrees Fahrenheit. And you'll see different estimates on that, but this is what I'm getting from my single source, the IPCC. Oh, and you say to yourself, we can't impact the whole planet. Well, yeah, you can. We were doing very well, totally destroying the ozone layer, a safety blanket around us by the use of freons and other ozone destroying catalysts. And that's what we'll talk about in the next video.